For this first example, we're sketching the graph of a rational function. We're just looking at more complicated ones in this lesson. So I see that the exponents are both squares in the numerator and denominator. I'd like to figure out, is there a vertical asymptote, horizontal asymptote, any x or y intercepts, and we can use the same ideas from the previous lesson. The only difference here is I'm going to factor the expression. So I can write this as, let's see, I have x. If I do plus 2 and minus 1, that will add to the x but give me a negative 2 at the end. And also, let's see, for the denominator, that's going to be x minus 7 and x plus 6. This will be useful for figuring out where things are located on this graph. So let's start with the vertical asymptotes. All right, so for the vertical asymptote, that's going to be wherever your denominator is 0. And once it's factored, you can say, well, that's going to be x is equal to negative 6 and also positive 7. There has to be vertical asymptotes at those places. You can even put those on the graph right now if you'd like. So let's see. We have negative 6 and we have positive 7. Okay, if I want, let's say, the horizontal asymptote, okay, I have to go back to the original function and look at the ratio of the numbers in front of the largest powered x terms. So it's going to be 1 divided by 1, or just, I'll write that as y is equal to 1, and I'll place that on my graph. So I have a horizontal asymptote, I have 2 vertical asymptotes. All right, if I want my, let's say, x-intercepts, that's going to be wherever the numerator is equal to 0. And because it's factored, I know both negative 2 and 1 make the numerator 0, so there's actually 2 x-intercepts. So let's see, that was negative 2 and 1. And lastly, I'll get the y-intercept. I have to go back to the original graph for that, but it's going to be the ratio of the last 2 numbers. So negative 2 over negative 42. It's going to be a positive number. It's going to be 0, positive 2 over 42, or 1 over 21, whatever. That's a really small number. I mean, I can barely really fit that in here. This is kind of just above the axis, right here. So if I want to sketch my graph, I'm going to draw a function going through these 3 points and approaching both of my asymptotes. And then also, the graph approaches the asymptotes here. And this is a sketch of my graph. So again, using the same idea, plot the asymptotes, the x and y intercepts, and your graph has to go through them. So you could actually compare this to a graph that you get in Desmos just to make sure that they actually look the same. And there's one other feature, though, that's a little strange about this graph, and that is this graph actually crosses over the horizontal asymptote. So it should cross y is equal to 1. And to figure out where that happens, it'll look like it's difficult to do, but it's actually pretty easy. I'm going to take my equation, and I'm going to set it equal to 1, which is in fact the horizontal asymptote. And I'm asking, does my equation ever equal 1? To solve this messy equation for x, looks like a mess, but I can multiply both sides by the denominator on the left, which gives me x squared plus x minus 2 is equal to x squared minus x minus 42. And this is nice because the x squareds cancel. I can add x to both sides, which gives me 2x, and I can add 2 to both sides, which gives me negative 40, and if I divide both sides by 2, I get negative 20. So I can't actually fit this on the 10 by 10 window, essentially, that I've graphed my function in, but something odd happens. Over at x is equal to negative 20, so if you start here and go this way out to 20, this function actually equals 1. It drops below it a little bit, and then it's always below the graph there. We found every place that this graph is equal to 1, and it only happens once. It happens at negative 20. The graph actually equals it, crosses over, and stays below it and approaches it from the other side. But for the graph I'm looking at, I really just want to focus on this 10 by 10 window, get the main features of the graph. I'll use this later on, but we'll talk about that in a future example. All right, for example 2, same idea, just different variation where I'm going to sketch a graph by using asymptotes and intercepts. So first I'm going to factor my equation. Let's see, this is going to be x minus 5 and x plus 1. The denominator is going to be, okay, that's going to be x plus 7 and x minus 3. And I'll list out a few things. So an x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and then I'll see if this graph crosses over the horizontal asymptote. So we'll solve that too. Okay, so for my x-intercepts, that's where the numerator is 0. I can clearly see that that's at 5, 0, as well as negative 1, 0. The y-intercept is the ratio of the last two numbers, which is 0 divided by, it's going to be negative 5 over negative 21. I'll just write that as positive 5 over 21. It's just a small number close to 0. The vertical asymptotes are located at x equals negative 7 and also x is equal to positive 3. That's where the denominator is 0. And actually the horizontal asymptote, again, it's just 1. And let's actually graph from here. So we have y equals 1. That was the horizontal asymptote. X equals 3 and x equals negative 7 are my two vertical asymptotes. I have two x-intercepts. One is at 5, 0. One is at negative 1, 0. And then it crosses over the y-axis at 0 and then 5 over 21, so look right about there. Okay, my graph has to go through every intercept and approach the asymptotes, so I'm thinking the graph has to look like this. Over here, it would have to be below, like that. And then over here, it has to be above because there's no x-intercepts below there, but this is, again, a basic sketch of the graph just using some of the key features on the graph. But now the question is, does this graph cross y is equal to 1? And you can actually see it this time. It does. Right here. There's actually a spot where this thing crosses over the horizontal asymptote. And I want to figure out where that is. And again, our way of doing that was to just take your equation, x squared minus 4x minus 5, divided by x squared plus 4x minus 21, and just set it equal to 1. This will result in a really simple equation because, again, you're just cross multiplying x squared plus 4x minus 21 to both sides. And it's going to work out that the quadratic goes away. The squared portions just cancel. This time I'm going to add 20 to both sides, and I'm going to add 4x to both sides, divide both sides by 8, and I have my value of 15 over 8. So it's actually a little bit bigger than 1. It's actually less than 2, so my graph is a little off, but that should be this spot right here, like this location where it crosses over the x-axis. If I was to fix my graph, I think what I would have done is mark that right about here. This thing would have come up a little bit more steep and then approached this way. But you should be able to check this value in a table, and this is a reasonable sketch of the rational function x squared minus 4x minus 5 divided by x squared plus 4x minus 21. And lastly, just one more variation on a rational function. This one is a little different than the previous two because if you look at the numerator, it's just an x to the first, and the denominator has an x squared. And I want to do the same thing though, find any intercepts or asymptotes and see what we end up with. And if I try to factor this equation, I actually can't even factor the numerator. I have to leave it as x minus 1. The denominator factors really nicely as x minus 3 times x plus 3. And so now if I list out an x-intercept, y-intercept, a vertical asymptote, and a horizontal asymptote, those things should be pretty easy to find. Let's see. For my x-intercept, that's where the numerator is 0. There's only one place where that could happen. It's going to be 1, 0. Okay. Now the y-intercept, again, it's just the ratio of the last two terms, so it's going to be a positive 1/9, 0, positive 1/9. Vertical asymptote has to be any place the denominator is 0, so it's going to be both 3, 0 and negative 3, 0. Now this where it gets a little strange. The horizontal asymptote, there's no x squared in the numerator. So if you want to be really careful, you could say this. If you want to compare x squareds to x squareds, the horizontal asymptote should be y is equal to 0 from the x squared in the top, and then 1 from the x squared in the denominator, and that's just y is equal to 0. So it turns out that y equals 0 is going to be the horizontal asymptote of this function. This will happen any time that the degree of the denominator is larger than the degree of the numerator. 0 will always be the place that the graph goes to on its ends. So we have 3 and negative 3 for the vertical asymptotes. 1/9, so that's where it crosses over the y-axis, and then 1, 0 is where it crosses over the x-axis. And note that the x-intercept actually is on the horizontal asymptote, so this thing actually does cross the horizontal asymptote. If I sketch in the graph around it, I know the graph has to drop down like this, going through those 2 points and approaching both of the asymptotes. And as for the ends of the graph, I know that it has to be above over here because we're going to get some positive numbers back from the graph, and then we're going to get negative values over here, so I know it has to be below. But this is the sketch of this particular rational function, and comparing this to something on Desmos would definitely be a good idea. Make sure our points match up, but here is our final sketch.